Okay, where are you? Okay. How are you?
I'm surviving. How are you?
I'm all right.
Mm.
Yeah. So we are going to start. It's not anything crazy. It's something very okay. So we are going to design a parking lot system. Yeah, that's what we are going to design.
A parking lot system.
Yeah.
Okay, cool. Can you please give me more context around this parking lot system? What it is exactly?
Okay, so for the purpose of this interview, we are just going to design a very no one is timing, so I think Papa you can time. We are going to design a very like simple parking lot system. We expect the parking lot system. We expect users to be able to reserve a spot at the parking lot system. We also expect users, so a user can come to our parking lot system and reserve a spot. Also, before you reserve a spot, you should be able to pay for the spot, right, at like an hourly rate. But yeah, that's what we are going to look at.
Okay, no problem. So we are designing a parking lot system that allows users to reserve the parking spots and also pay for the parking spots essentially.
Yeah, pay for the spots
Okay, no problem.
hourly at an hourly rate.
At an hourly rate. Okay,
Yeah.
right, no problem. Do you have any idea on the skill that we are going to handle, if any?
Okay. Yeah. Even though we are just offering basics of a normal parking lot system, we would expect that our system will scale, right? Because people will start using it very frequently. So
Okay,
we are expecting a lot of load, but then we would want our system to be to have low latency, even though we are expecting a lot of load.
okay. All right, thank you. So I'm going to go ahead with some assumptions based on what you just said. I hope that's fine.
Yeah, you can.
Okay, no problem. So I'm going to list some assumptions or some stuff that our system will do by as far as skill is concerned. So I'm going to just list them out. So I'll start with traffic. So
Okay.
since you mentioned that we'll be expecting a lot of load, I'm going to say that we would have, let's say, 1 million daily active users,
That's fine.
and maybe in our peak hours, we would get like 5,000 requests per second. I hope that's fine.
Yeah, that's fine.
Okay, no problem. So another thing that I would also want to mention is that so before you mentioned that there will be a high traffic due to frequency of access. So I'm assuming that before a user tries to reserve for a spot, you have to check if the spot is available, right?
Yes,
So
exactly.
if I'm a user and then I'm coming to check in, I'll do some availability checks. So I'm also going to assume that the user would maybe each user would do 5 availability checks, right, per session. So let's say each user does 5. And how much time do I have, please, per
Um,
session?
timekeeper.
Okay, I'm going to go ahead regardless, which makes this a read heavy system. So I'm going to say this our system will be read heavy just solely based off the fact that each user does 5 availability checks, making it like 1 million times 5, right, for each user. So our system will be read heavy, and um, yeah, what else do I would also say that, okay, so since users also have to pay for the spot, right? I would have to factor in some kind of buffer or a hold time before payment, right? Maybe if you say that you want to reserve a parking spot, we'll give you an amount of or a period of time that you have to pay before we actually give the system or the spot to somebody else. So I would say that if you try to reserve a spot, we'll give you 5 minutes. So I would say a 5 minutes buffer um, before payment, right? If payment fails, we'll just cancel your spot or whatever. And so this is the assumptions that I'll go by as far as traffic is concerned. And so yes, I would think
Um,
I missed anything. Is there something you think I missed? But
so
this is,
I want to be sure. Are you prioritizing availability over consistency? Or
okay, that's a good question. So um I'm going to prioritize consistency based off the fact that I think for the reservation, right? Since reservation is required, and we also don't want one particular user to book for a spot twice, right? So I would say our system has to be strongly consistent. And so yes, if I was to enter the API side, I would say I would use some kind of transaction semantics to allocate a spot for each user. But I would say I'm prioritizing consistency. I hope that's fine.
okay, yeah, that's fine.
No problem. So yes, let me go ahead and list some functional requirements. Do you have any functional requirements for me, or I'm just
Oh,
trying to go off the assumptions based on what you gave me, the context?
I actually did mention them. Those are the two you have at the top. The reserve and
Okay,
apartment spots.
okay, no problem.
You know,
I understood them as a high level description. It's fine, no problem. So reserve a parking spot and just pay.
yeah.
Interesting. Okay, no problem. Um, I don't know why I'm having incoherent thoughts right now. But
So what are they? You can talk about them.
I feel like I'm thinking about a lot of things at the same time. But based on these requirements that you gave me, I'll just stick to this. Maybe if you want me
Okay.
to add something else, I'll add.
Yeah, the functional requirements are a bit straightforward. I
Yeah.
think
Okay.
we can
Right.
look at the non-functional requirements. I think you've already spelled some of them out.
Okay.
Uh, so we can go on and look at that.
Okay. No problem. So I'm going to go ahead and list some high level components that I'll use for our system over here, right? So let me just write high level components. The first one would need is an API server, right? Basically. So we'll
Yeah.
have an API server which will accept requests to reserve a parking spot and also accept payment. So I'll say an API server to accept, reserve, and payment endpoints. And also for my choice of database, I'll go with a relational database. I think something like Postgres would work fine for me over here because we would have to find a way to link reservations with payments. And so I think that if I go with a relational database, it would make perfect sense for me. And so for choice of database, to I'll go with Postgres.
Okay.
Also for some asset properties as well, I forgot to mention that, right? So I'll also go with Postgres for that. And maybe we can have some form of cache, right? But I wouldn't want to say that caching would be a requirement for our system, but for extreme contention, or maybe if we want to show immediate load counts, right? For instance, if I'm a user and then I come and I say, oh, maybe I want to reserve this spot, and then we've given you 5 minutes to pay, right? Maybe we can cache that so that you know. But I don't really think it's needed, so I'm going to skip this. Maybe when I'm trying to optimize my system, I'll put it in there. But
Yeah, we can always come back and like
right, no problem. And I'll also need a payment gateway. I assume that I'm not going to build a payment gateway from scratch,
Okay.
right? I would say a payment gateway, which is obviously an external one. It will do some odd checks. It will send webhooks, etc., etc. I'm not going to.
Yeah.
And then what else? What else? So I said I'll give each user a 5 minute buffer before payment, where if the payment fails, if the payment fails, we just cancel that reservation, right? So I'm also going to add some small worker somewhere that would essentially cancel um, all reservations that expire, let's say outside the 5 minute window, if maybe the person didn't pay for it. So I'm going to add like a small worker, right, which will cancel expired codes.
Not to cut you, are
Okay.
you going to go back to the functional requirements, or you're
Yes.
assuming?
No. Do you before I even go there? Do you have any non-functional requirements for me? Because I know that you asked me if I was prioritizing availability over consistency, which was something I noted, but I wanted to come there later. But I think it's fine. Do you
Okay.
have any other non-functional requirements for
If we'll go there later, you just complete this. Then
Okay, then I think I'm even there now, right? Because I think I'm done listing my high level components. So if you can state the non-functional
okay.
requirements.
So yeah, the first one you mentioned, like you're prioritizing um, consistency.
Mhm.
Um, I also think I've already mentioned that our system, we want our system to have low latency.
I don't think I can hear you properly. I'm not sure if it's just me, but
Oh,
the voice seems a bit far.
hello. Do you
Yeah,
guys hear me?
I can hear you now, but I feel like it was breaking.
Oh, okay.
Okay,
Sorry about that. Um, I mentioned low latency.
okay.
Yeah, and I think for this system, since we are dealing with money, we want to also have a um, security. We would want to make sure that our system is secure, so that we wouldn't like you know do anything to the money that we can't trace, which would cause our system to not like be reliable, right? I think someone has a hand up. I don't know if it's a question, but it's timed. So if it's a question, can you please note it down? If it's not, if oh, or was it a mistake?
I was asking if we are focusing on how to pack, or like that we are only focusing on the whole like user story of parking. So like on how to park. You have to consider like certain cases like maybe parking bicycles and motorcycles and cars, right? And these are like separate parking spaces. So when you say like design a parking lot, I was like kind of confused if we are designing the parking lot or it's just like the booking side.
Um, well, I think maybe for a more extended session, we could look at like different types of parking. But then for this, I think we are more focused on like the booking and then just how you can reserve a parking spot. Mostly like more focused on like the reserving because there's something there that I think we would want to touch on, and then also like the payment of it so as well. So that's those are just two things we want to focus on.
Sure, thanks.
Okay.
Okay. Also, since you mentioned security, I think you were saying something before it came up, but I also wanted to ask that does this security um, um, does it only have to do with the money part? Do you mean security in terms of like auth or just us handling user money? Is that it?
I mean, we would want to handle security on both sides, both the user and then their money they are paying. So I think you already have taken care of security with in terms of like the payment gateway. I was just mentioning this like in terms of like the user as well.
Okay, okay, that's fine. Right. So I'm going to Since I've already listed my core component over here, I think I have enough information from this and also this to start designing some form of data models. So I'm going to also
All right.
list the various entities and models that I'll be using, right? So the first thing that since the first thing I want to do is to reserve a parking spot, I think I'll have an entity for the spot itself, right? So maybe right. So the first one will be the spot, and then I would say the spot will have an ID, obviously. So I'll make this a UUID, and then I'd say the spot number, right? The spot number and the status. Yeah, I think it's just the status that I'd need for this. Just for this, right? So the spot will have our ID, the spot number, and then the status. And then since we also want to reserve the spot itself, I'll also need a model for the reservation. So I'll also create one for reservation. And then that one will also have an ID, ID. We'll also add the user ID over here. And then, so when you reserve, I assume that you want to reserve it for a period of time. So it will have some form of start time and then end times as well. So these will be timestamps. And then we'll also have the status of the reservation because, mind you, we want to pay for the reservation, right? So we'll have the status. So, what else will I need? So we have the user ID, start time, end time status.
So who is making the reservation?
Who is making
The reservation. Like which entity is making
the user, right? I'll come there. I just wanted to define the entities that were core to the system I was designing before I get to any other
it?
extraneous entities. That's why I linked it with the user ID. I
Okay.
hope
Okay.
that is fine.
That's fine.
Okay, perfect. So also the amounts that we are paying for the reservation, and then um what else? I think this is fine for me. This is fine for me. I can always come back to another.
I think one thing we want to do is to check if a reservation is available or a spot is available.
Um,
That's the status, right?
is it mine? I don't think I can hear you honestly.
Hello.
Yeah,
Oh, I'm just asking if you are taking care of an is available field with the status. Can you hear me properly?
yes, I can.
Okay.
So the status that you are talking about for the reservation is something I've added to the spot, right? So if you want to reserve a spot, the status here is for us to check if the spot is actually available before you try to create the reservation.
Okay.
So this status over here, maybe I should add some kind of constants that will give. I'll say the default to be pending, right? Maybe the reservation is pending. Maybe somebody has paid for it or somebody wants to reserve it, but they've not paid for it yet. I'll say it to be pending, but then we can also have confirmed. We can
Okay.
also have cancelled,
Okay.
right? Yeah, I think this is fine. And
You may want to like pick up pace because we've spent like 30 minutes. So.
how much time do I have? Because I honestly don't think I started at 9 on the dot.
No, you didn't, but like you have spent 30 minutes.
30 minutes.
Yeah. Right.
Interesting. Okay, perfect. That is fine. That is fine. So that
You
the
have
third,
26 more minutes. So yeah.
I have 6 more minutes.
26, 26.
Okay.
Sorry, I made a mistake. You started at 9:10, and so you have 26 more minutes.
Okay, no problem. Then I have to speed up. That's
Yeah.
fine. Okay. So the another table I'll add would be the payment since we also want to pay. So I'll say I'll also create a payments table and this would have our ID and we want to link the payments to a particular reservation. So I'll say we would have a reservation ID, which would be a UUID and this would reference our reservation entity, right? So I'll say yeah, I can even leave it like this. Let me and then the other thing would be the status of the payment, the amount, and then maybe any payload that we send to the payment provider, right? So provider payload, if any. I would also add an idempotency key. Um, Also, I intentionally excluded created ads, updated ads from these entities. I hope that's fine. I don't really want to go into the semantics of all of that. I just listed all the fields that I think were
I mean, now
necessary.
that you mention, that's fine.
Okay, no problem. And um, sports reservation payments, and then the final thing I'll need is the person actually trying to make a payment or make a reservation, right? So this is linked. The spot is linked to the reservation. Reservation is linked to the user. Reservation is linked to the payment. I'll add the final ones for user. The ID, maybe the email. Yeah, I'll just go with the ID and the email just for statistics. So
Okay.
this would be my core entities that I'll be using for my system, right? And
Right.
so um I also want to talk about the should I say the end-to-end flow of how a reservation would be created, right? And before I get to any lower level details, I want to map out how I think the whole thing would work like end to end, from let's say making a request to hit our API server to actually getting the spots that you are trying to pay and reserve for.
Mm-hmm.
I hope that is also fine.
You mean like you're going to go ahead and design a high level?
Yes.
Okay.
Okay, cool. So I would say reservation creation. So the first one, I would say so we will have a client. Since one of our core components is an API server, I assume that, or I know that there's a client that will make a request to hit our API endpoints, right, on our server. So I would say that our client makes a request to client makes requests to the reservations endpoint to make a reservation, essentially. But the kind of payload that they will add to this reservation endpoint, I believe, since you are trying to reserve for something, we would have to add the start time and then the end time that you are trying to, essentially, how long your reservation will take. So client makes request reservations endpoints with start time and end time. We can also add an idempotency key, right? With idempotency key. And the next thing that would happen will be that, so it hits the request will hit our API server, and then our API server will try to create a reservation for our client or for our user. And so our API server will try to perform some validation checks. I mean, it's the reservation being created is essentially an insert statement into our DB, right? And so whenever we are trying to create a reservation, by default, the status is pending. So our API server tries to do that. But then before that, it has to check. So I think that we also need um, so the start time and then the end time. Okay, then it's fine. We can check. So I would say that the API server starts. So it wants to insert or create a new reservation in our database with a new. It wants to essentially create.
I feel like you are complicating it a bit
Mhm.
because I think this is actually a kind of deep dive. I think what we could do here is essentially just draw some boxes and see how we are going to
Okay,
handle
okay,
it.
no problem.
Because here you're typing and it's taking
Right,
time,
right,
right?
no problem. That's fine.
So let's try and visualize this to see,
Okay, okay,
and
perfect.
then we'll deep dive on
Okay,
why how you are going to do the reservation and all of that.
okay, cool, cool. Thank you. So we'll have our clients here, and then our client makes. So we also have our API server over here. And since we want to handle skill, we can have multiple API servers. Maybe we can have a cluster, right? So I'd say you have, let's say, a cluster of servers like this, and then these are behind some form of load balancer. No, exactly like a load balancer, right? So we have an ALB somewhere here that would distribute requests to our API server. So I'll say this is our server, and we have our load balancer here, and this is our client. So our client makes a request to our load balancer, and then our load balancer just essentially distributes the request, right? I'm thinking of also having an API gateway which sits on the LB level, which will do things like authentication checks and whatnot. So I'm just going to so let me do this. So there will be an API gateway that handles things like security, like auth checks and rate limiting, if any, right? Okay. So our client makes a request to our server. Our server also tries to insert something in our DB. So we can also have a cluster of DBs somewhere at the back. So this will be our Postgres DB. And so when we make a request to the reservations endpoint, let me see. How do I make this? Let me push this. Let me do this. Let me push this. So right. So we make the request to the reservations endpoint, and then we try to create a new reservation, right? So our server will try to do that. Let me put this.
Okay, so can we just go back to the functional requirements to,
Cool.
because I think you are still on the reservation. There's another thing we just have to
Right.
take care of.
Okay. Can you point me in the right direction?
Yeah, so now I think this is your user journey to creating a reservation. So
Mhm.
can we look at the high level user journey of paying for a spot?
Paying for a spot.
Yeah.
Okay, no problem. Um, so if a user is trying to pay for the spot, like I was doing over here, I wanted to add that now we know that when a user tries to reserve a spot, right, we essentially give them a 5 minutes buffer before payment. So I wanted to say that if a request hits our reservation endpoint, the API server adds a new field called. So we have to add a new field here called an expires at, right? Which would basically track how long the user has before they make payment. And so when the reservation is actually being created, right? Let's assume that we hit our reservations endpoint and our server creates the actual reservation entity in our database with an expired at 5 minutes from now. And so the user has 5 minutes to pay for this reservation. And so what we will do is that the API server creates how do I call this? It creates a payment intent, if that's the right word, with um it creates a payment intent with an idempotency key, right? Which would essentially add to our external payment provider. And so if let's say so I'm going to assume that, or I'm not even going to assume, I'll just say that the payment for the reservation also happens as part of the reservation flow, right? And so if let's say we create a reservation that has an ID of one, um, let's say we created a reservation with an ID of ABC, right? What's those?
Mhm.
Okay, if you created a reservation with an ID of ABC, now you have 5 minutes to pay for this, and so our server would now have to hit our external payment provider, for the user to actually make the payment. And so with this one, so I'll assume that would let's say it has maybe a pay endpoint, right? Maybe pay, right? So you try to pay for this reservation, and how do I handle this? Interesting. So if you want to pay,
Exactly are you saying how do you handle? Because I'm trying to.
So since I when I say how do I handle it, I'm trying to just also map out various API endpoints that our hypothetical payment provider would give to us so that we can link it to what we are building over here. That's essentially what I mean by how do I handle it. So,
Mm.
I'm also trying to map out the core endpoints or maybe the core components in our payment provider. I don't know, but that's just what I'm thinking about.
I mean,
That's fine.
your flow of making a reservation and based off whether I actually make a payment, right? Because
Yes,
I need to pay
yes,
before the reservation becomes
yes.
confirmed, right?
Right, right.
So I don't. I think that's okay.
Right. Okay. So also when you create the reservation, since you have 5 minutes to pay, the status that gets returned to you is pending. So now you have to pay for it for the status to change to confirmed.
Mm-hmm.
And so this is essentially what our external payment provider would do for us. And so we would make a request to the slash pay endpoint to our external payment endpoint. And then this request would include the reservation ID. I'm not sure why my text is, I don't know. Can you give me a moment? So this would include our reservation ID, and then we would also add an expires at, since we need the expires at to actually check when the user actually paid for this. And then let me keep it at this. Maybe we can add an idempotency key to the headers, but I want to keep things minimalistic and improve when necessary.
Okay.
So this is what would send to our payment provider, and then if the payment actually succeeds, right, we will return a 201 successful to our server, which would in turn go and update the status of the reservation from pending to confirmed, right? So we return 201 if success. And so we make this, we have 5 minutes, we create, it gets set to pending, we pay, returns 201, and then okay, we return back to our client, right? So
Mm-hmm.
there's a get for reservations, which would, so if payment is successful, right? If payment is successful, now the status of the reservation gets changed from pending confirmed to confirmed, and then it gets sent back to the client. So over here, the client can just complete the payments with whatever UI that they are using, but
Yeah.
essentially the payment has been successful on the back. And so um what else?
Okay.
Can
So
you
right now, I
Mhm.
think we have a somewhat working solution.
Okay,
So we said we want our system to have low latency, right?
okay,
I think the first one is consistency.
okay.
So yeah, before we go to low latency, I think we've already looked at the security aspect. So before we go to low latency, how exactly are we going to ensure that no two people can reserve the same spot? Um, yeah.
Okay. So in order for me to prevent two people from reserving the same spot, what I can do is that I can introduce some form of primitive locking, whereby if one particular user tries to reserve a parking spot, I would essentially lock that spot until the 5 minutes window is off, and then we release it for another user to actually come and try to reserve that spot. And I can do that. I think I'm going to use a cache to do that. And so if, for instance, user A tries to make a request to reserve a spot, right? What I'm going to do is that I will have a cache. I would have sorry about that. I will have a cache over here. That's the key would be the spot ID,
Mm-hmm.
the spot ID, and then what's interesting. The key would be the spot ID, and then the value would be I would say the spot status, basically. So I'm going to cache this for 5 minutes, since I think 5 minutes is
Okay.
basically how long each user has to try and reserve the spot. So I'll cache this for 5 minutes. And so if user A tries to reserve the spot, we'll cache the spot ID with the status, and then it hits the server. The user tries to pay, and then before we return the 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 reservation, and then we update the status to confirmed to our user, I would also update the spot status over here to from, let's say, available. So I'd say by default, right, it's either available or taken. So
Sorry, I lost you for a second. Are you doing? Are you sorry? Can you just backtrack to how
yes,
you are updating the cache? I think you're also updating the DB. I'm not sure.
yes. So the what I'm actually doing over here is that I'm saying that when the user tries to make a request to reserve a spot, right? We
Mm-hmm.
know that, or what I'm doing is that by default the spot status is pending. And
Okay.
so if the user I'm trying to describe a success flow. So if the user is able to pay within the 5 minutes window, we before we return. So let me actually mention this over here too. So obviously we would update or would create our reservation here with interesting. So what I'm actually going to do over here is that since I mentioned a worker that would cancel expired holds, right? Before our reservation, or before we make the user try to pay for this reservation, we know that it has already been created in our DB with the status of pending, right? And so my worker, another thing that my worker would also do is that it would check if that the payment for that spot or that reservation payment was successful, and it goes to update it in our database from pending to confirmed, so that we will have the what's it called, the updated one in our database as well. But then what I was saying as far as the logs was concerned is that before I return the success response back to our user, right, I'd also update the cache before doing it based on the spot ID. And so what I can also do, okay, so I believe I forgot, oh, I believe I forgot to add a spot ID to my, sorry, how do I, okay, a spot ID to my reservation since it's a spot that we are reserving. So
Yeah.
spot ID, right? So I'll also update the spot and then the status from available to taken, and then we return the response to the client. Now that I think about it, I don't even think that the 5 minutes TTL is actually going to be enough, because if after 5 minutes it's okay. What I'm going to do over here is that I can actually maintain the 5 minutes, and I can sync my cache with my DB, right? And so before the reservation is actually being made, and I cache the spot ID and then the status that hits our endpoint, I also create it in the DB. But then the status here is available, and so when the payment is successful, and then my worker is actually going to update the status of the reservation, it would also simultaneously update the status of the spot in our database to from available to taken. And then before it returns the response to the it returns the response to the client, right, it also updates the status of the spot. So in this particular case, any user that tries to make a request from now till 5 minutes later, after maybe user A tried to create their request, it checks our cache, right? So our cache here would be some form of a write through, and then so it checks if the spot that the user is trying to reserve is available. If it's available, obviously the request would go through. But then if it's taken, I'll just return some conflict response. Maybe I'll do a 409 conflict if the the spot has been taken, right? So I'll do a 409 if spot is taken. So this is how I'm going to handle two users or even multiple users from reserving six spots. I'll be available to answer any questions if any.
So I'm guessing. Uh, okay. So okay, I think it's fine with me, to be
Okay.
honest. I don't know if primitive locking and distributed locking are the same thing. Um,
Okay.
but
Okay.
yeah, so like I would want to know like what's. I mean, you've explained what it is, right? But then I just wanted to put that,
Mm.
put a
Also,
tap.
if I may add this, I think that locking, me using locking here was not to be taken in the literal sense, because what I'm doing is essentially just a cache, a write through cache. We just check the cache if the status is available. If it's available, it goes through. If not, but I'm calling it a lock because of the TTL that we've set on the.
Oh, I do think it's a lock.
Oh, okay, perfect,
I'm
perfect.
not saying it's not a lock.
Okay, no problem. Then.
Yeah, I think we have 5 minutes more. So can you just brush up on how you are going to handle the low latency? Um,
Okay, no problem. And so I think that by so we have 1 million active users per day, and then we also have like 5,000 requests per second during peak hours. And so for me to make sure that my system is fast, first of all, I believe that me having the load balancer here essentially handles. So my load balancer here has an API gateway which handles rate limiting, and it also, I've lost my train of thoughts.
how are
It
you?
also distributes,
Okay,
sorry, okay, it also
but
distributes requests across my cluster of service, right?
okay,
And so I believe that if we have 1 million, or we have 5,000 requests coming in each second, right, we have limited spots available, and each spot that is being reserved has also been cached. Our cache here could also be distributed, so I'm going to distribute my cache over here. um I'm going to have like multiple caches, over here, so that before the request actually hits our server, I believe that a lot of them would have already been bounced on the cache level before it hits our server. And so I think that our system would be pretty fast, just solely based off of this. But other than that, another thing that I would want to say would be that if maybe we are in a peak hour, and then we are getting 5,000 requests per second, and for some reason it ends up hitting our server, right? Um, we are looking at we are looking at 5,000 requests hitting our server. I think our server should be able to handle that, because it's distributed and we can scale as and when necessary. And also our database can also handle these shared connections with some form of a connection pool. And so I'm not sure if there's something else I might have missed, but I believe that what I have in place so far would make our system pretty fast, in my opinion.
okay. Um, I personally don't have questions, but I think people have questions. I have questions, but they are not. Um, I'll ask them later. They are not in scope of. I think people have questions in scope of the
Okay.
interview. So, I also think we have just 5 minutes or 3 minutes more. So I would allow for questions. I think Jerry wanted to ask a question. So Jerry, you can go then.
Mm,
So before
Ephraim first.
okay, so like we are just taking time for questions. So I think the interview has ended here because we just have like two. So these questions are for you, Ernest, Ephraim, Jerry,
Okay.
then Prince.
Yeah,
Ephraim.
can you hear me?
Yes, I can.
Yeah. So I wanted to ask, you are building something like a booking system,
Right.
right? And there's this common problem when it comes to like booking, which we all know as like resale, right? So someone can hoard the bookings, like they can book multiple slots and um, they can resell them. And I think from a business logic, that's not going to be like something you want your system to be at that kind of risk, right?
Right.
So maybe I think you might want something that would limit the number of like booking slots that each user can get, or maybe
Right.
you can tie them to just one. But I just wanted to know how you'd go about that. I don't know if maybe the design is done or you are just going to explain.
Um, I I'm not sure if my interviewer has something to say about this, but is this not a little out of scope per the requirements I was given? If my interviewer can share.
Yeah, it is out of scope, but
Okay, okay, sure.
I'm sure we can tackle it, like later. once we are done hearing the other questions.
Yeah.
Jerry,
Okay. Yeah. All right. So I think my first question was initially how you were going to how you were planning of scaling like your cash, but I think did you mention it at the end what how you were going to do it? Because if you are doing like a rise through, it
Hmm.
means all every time there's a request to the load balancer, it has to go through your cash, and you are kind of
Right.
moving
Right.
every traffic there first.
Yeah.
So how are you planning of
Um.
scaling that?
So I mentioned that my servers, my DBs, and my caches would be in some form of a cluster, right? They would be clustered. And so, as far as scaling is concerned, also prompt me if maybe I'm not answering your question. I believe these clusters would already handle my scaling needs for me, but I will do it horizontally, right? So I feel like it should be fine because we can scale to as many as we need to handle whatever load is coming in. So that's pretty much my plan for scaling, basically. I'm not sure if there's something else that I should do to scale my cash, but that was it for me.
Mm, and do you have like, I don't know if it's out of scope, but do you have like a particular, because it would depend on the kind of data you're writing in, that would
Right,
determine like whether you're using Redis, Memcached, or whatever.
right,
Do you have
right.
like uh I mean, if it's out of school, you can just tell me it's out of
No
school.
problem.
How like that.
Yeah.
I mean, I was going
You're
to ask.
asking if I have a choice of what? A choice of cash?
Yeah, and
Yeah.
then maybe I
I,
can.
I don't want to mention an actual caching product, but this is pretty much a key value cache since I'm just storing the spot ID and then the status. Maybe we can store a bunch of other stuff as uh, instead of our status, we can cache like some actual payload. But I felt like the spot ID and the status was just enough for me. So pretty much any key value cache would do. So
Mm,
Redis, if I
I
may.
think for the purpose of these interviews, we don't try to
Right.
like go
okay,
into details. Maybe
okay,
after
okay,
the interview, then I was going to actually ask what cash and maybe what payment external payment service that he was going to use. But yeah, that's like outside of the interview.
okay. My second question is also concerning the payment, right?
Okay.
I didn't see. So it's like you were, well, I understand, but you were more focused on your system, but
Right.
it looks like you forgot the the payment is
Payment aspect
actually,
of it.
yeah, and
Right.
it can be a bottleneck
Yes.
because it's external. If you
Right.
do a TTL of 5 minutes, and let's say it's a Black Friday,
Hmm.
and lots of people are coming into the parking lot, and also other um, users are using that same payment gateway for like maybe it's some
Yeah,
other company, right?
Right.
How is there a way you are planning of like preventing that from being, it will be a bottleneck for some time, but
Right.
I like, do you have any plans on that?
Honestly, off the top of my head, no, I don't, because I, like you said, and rightfully so, I was actually more focused on the internals than any extraneous variables, which might have also been a mistake on my part because I should have considered it. But off the top of my head, no, I didn't consider anything related to the bottleneck that you mentioned, and it's actually a valid bottleneck, but I just don't have anything on top of my
All right,
head. Right.
thank you, sir.
Jerry, do you have something
Hey, something for
for the
like
bottom
doing that.
payment?
No. I'm just thinking of it because it's, if it's
So
external, yeah.
what I can add or what I can say is that for the purpose of my interview, and my interviewer said that she wanted to also ask for the choice of payment provider. And if she asked, I would have said none because this was like a hypothetical payment system that I was essentially trying to integrate into what I was building over here. And so before I even drew the API, I was saying that I was trying to map out these hypothetical API. So I'm assuming that I don't want to say that the system would be 99.9% perfect, but um, let's just say that when it's Black Friday, the payment provider will also scale to handle
Okay.
whatever. But if I were to also say something, I think that my worker here can do something related to this, right? We can add like some. Would that even fix it? Maybe we can increase the time that I can increase the time that I'm caching over here, so that at least we can
Hey, you're going to increase the time. I actually was going to say that isn't your time to live
during the
so
time.
much.
Okay, I'm trying to come up with a solution on the spot. If it's not ideal, definitely it's not ideal, and we can't do it. But I was trying to see if we can handle this bottleneck with the payment provider. So if I may, it might not necessarily be realistic, but
Oh, okay.
I was.
I mean, what I was thinking of